Hello, I am Rudaiba. I am going to present my paper, which is InnerEye, a tale on images filtered using Instagram filters. How do we interact with them and how can we automatically identify the extent of filtering? Here is the overview of this presentation. First, I will discuss the problem. Then, I will show the methodology of our study, the online surveys and the implementation of our system InnerEye. Then I will discuss the evaluation of InnerEye and conclusion and future work. The first research question that we explore is finding out if there is any prevalence of filtered images shared on social media and how users perceive the extent of applying filters over images with bare eyes. The second research question is how users appreciate the help of an automated tool in identifying the extent of applying filters over an image, and if so, why. The third research question is what are the components of an automated tool for identifying whether an image is filtered or not, and do people appreciate using such a tool. Here are the methodology of our study. First, we conduct a series of surveys to find out users' perspectives of filtered images and their ability to detect the extent of filtering in a filtered image. Then, we design a web tool which we call InnerEye that has the ability to detect and quantify the extent of filtering applied to an image. Next, we perform user evaluation of InnerEye and find out the user preference in perceiving the outcomes of such a tool. Now, we will discuss the online surveys that we performed in our study. We conducted 4 chronological series of surveys. The first one focused on varied demography on their experience towards social media and filtered images. The second one found out the participants' preference toward specific filters and their agreement towards a specific filter. And the third one uncovers users' ability to quantify the extent of filters applied to an image. And the last one is the consolidated survey to verify the consistency of the results of our previous 3 surveys across demographic and temporal variations. The first survey where we find out users' experience with interacting through filtered images on social media. From figure A, we can see that many people feel that they are disturbed and misled by shared filtered images. And from figure B, we can see that a few number of people feels that social relationship gets built based on shared filtered images. Here we see some more results from the first survey. We see that Many users claim that they can identify filtered images with their bare eyes, but we can also see from figure B that many feel that they need an automated tool to detect filtered images for them. This implies that people are not confident in their ability to detect image filtration. The survey 2 focuses on the user's preference towards interacting with filtered images. Here we see three versions of images. Here we asked the participants about their preferred version of these three images. From the results that we see in the figure, we can see that people have varied tastes when it comes to image filtering preferences, and there is no universal agreement on what type of filters users will use. This implies that the task of detecting whether an image is filtered or not is a vast problem space, and user cannot reach an agreement. The survey 3, which focused on users' capability in quantifying the extent of image alteration. Here we can again see the three versions of images. Here we asked the participant to quantify the filtered version of these three images using percentage value. Here we can see the results of the survey. From figure A, we can see that users perceive the same filtered version of these three images differently, and also from figure B, we can see that user perceive their image components that were changed during the filtering of the images to a varying degree. All these imply that users cannot reach an agreement about quantifying the extent of filters applied to an image. Next, the consolidated survey, which is the final survey that we conduct to verify our findings from the previous surveys, which faced demographic and temporal variations. We noticed demographic variation in previous three surveys. To verify the results of our series of surveys, we designed the consolidated survey, preserving the demographic proportion of the participants. However, the results are comparable even in the presence of no demographic and temporal variations, which justify our findings from the previous surveys. Now we will discuss the summary of the survey results. There is no universal agreement on what type of filters users will use. We also find that user cannot reach an agreement about quantifying the extent of filters applied to an image. We further see that users are not confident in their ability to detect image alterations. Also, we see that an objective opinion about the originality of images can assist them in their interaction with filtered images. Therefore, we implemented InnerEye to enable users to identify how far an image is filtered or not, and to give them an quantification value about the extent of filters applied to an image. Now we will discuss about the implementation of our system InnerEye. InnerEye has two components, which are the predictor and the survey. The predictor provides a quantitative percentage value of the extent of an filter applied to an image and also a qualitative message about the possibility of an image being filtered, and the survey collects feedback from the tool from the users. Here we see the screenshot of our implemented system InnerEye. In the left side we can see the predictor, and in the right side we can see the survey. In the predictor we can see that we can choose a file of an image and we can click on the predict button, and this will show if the possibility of being filtered of that image is sure or not, and also it will show the extent of filtering. In the lower portion we can see the example of 4 versions of filtered images, and also in the right side we can see the survey which contains demographic information, collection questions, and also some survey questions such as possibility of being filtered is satisfactory or not, and also the extent of filtering option is satisfactory or not. This is how we collect the user responses for our evaluation from the survey in the right side of this screenshot. Now we will see that in this architecture of InnerEye. Here in the figure we can see that InnerEye classifier consists of a style encoder module and an content encoder module, an image decoder module, and a style predictor module. The classifier is co-trained for both image classification and image reconstruction tasks. We implemented the classifier to classify input images into two types, filtered and unfiltered. The challenge was to recognize how the appearance of colors of the object present in a filtered image is different from those in its unfiltered counterpart. Further, while constructing such a classifier, we had to consider different illumination conditions such as early morning, mid-afternoon, and evening. Now we will see the evaluation of InnerEye. We distributed our tool among 52 participants and we collected user experiences through the survey integrated into the tool that we have seen in the screenshot of our implemented system InnerEye. Now in the figure we can see the results of the evaluation of InnerEye. First we see the demographic information, then we see the qualitative description prediction of participants versus the model, and the quantitative description prediction of participants versus the model. We see that the participant preferred the results of our tool in a quantitative manner. We also observe that general agreement and disagreement towards our solution are nearly equalized, which is undesirable but quite expected. We hypothesized that as the opinions of the users toward filtered images are very divergent, their opinion toward a filtered image detection tool will be divergent. Thus, this hypothesis is justified from the results of the evaluation of InnerEye. Now, I will discuss about the conclusion and future mark of this study. Our survey result that we conducted showed that users cannot provide a unified view on the quantification of the extent of filters of different images. and also they design an automated tool to detect filter images. Inspired by the result of the survey, we built a custom web tool in InnerEye using a neural network model, and we evaluated the system. Also, we see that from the user evaluation after deploying the tool online that the efficacy of InnerEye and its acceptance among users. The future work. In this study, we focused on image filtering. We want to cover in future the other ways of image editing such as cropping, color adjustment, removal of objects from images, selective color change, etc. Also, in this study, we built the neural network classifier of InnerEye by decomposing an image into style and context. We want to explore how can we implement the decomposition of the classifier in a better way to achieve more classifier accuracy in the future. Thank you everyone.